Welcome back to my little DipTrace mini-series. And yeah, this was the schematic I created last time. I made some small changes, but that doesn't really matter. Uh, this time I'm showing you how I make a layout. And please keep in mind, it's not a tutorial, it's just my workflow, how I do it. Okay, so if you have a schematic and you check the schematic and there were no errors, I didn't use that last time, sorry. So of course you can verify electric rules. Um, then you can convert it to a PCB. Let's do that. Okay. And it asks you making PCB from schematic. Okay, you can use the schematic rules or use rules and settings from previous layout. I never cared about that, so I always use the schematic rules. And then we are in PCB layout. And first thing, just as a matter of course, save as. And this is my laboratory water bath. And yeah, it shows you there's already a file name for it, but it's a schematic front version 1. Done. The very first thing you should do, or I will do, and I have to look up some values here and parallel, is to define your board size. Or in this case, because this goes behind a front panel, I first should define my board size. Okay, place board outline. There it is. And I just you just draw a board outline, any board outline, because then as soon as I finished, and you finish with the enter key here. So, and after I draw an arbitrary board outline, I usually enter the dimensions in numbers instead of trying to fiddle around here. And my calculator tells me, my width is 143 millimeters, so half of that is 71.5. Control copy. So my first point here is at minus 71.5, and that one also at minus 71.5, and I'm metric here. I'm a metric guy, sorry. And these are at plus, and these are also plus. So, and for the height of the board, it will be a front board. That's 42 millimeters. I don't need a calculator for that. I can simply say, okay, Y is 21. Now let's place all that stuff, and you see it's crowded. It's really, really crowded. So let's get the small fries all out of the way for now. I know my rotary encoder will be somewhere down below. And I want my set display beside it. Okay, you see how crowded it's going to be. And now you have to let me think where I want to put the other displays. Something like that. But I don't know which display should be which? Okay, I need to think about that. Back in a sec. Okay, with the space I have, there's no perfect way to do it. So my set temperature, which I dial in with a rotary encoder, that will be beside the rotary encoder. Then I have that power LED, which needs to go somewhere there. And I have, usually the set temperature will be compared to an external sensor, and the temperature of that sensor is displayed here. In some cases, I won't have an external sensor, so I just measure another temperature, which is just an approximation. And then in addition, I have the heater here. Thing is, there will be another LED, which is not on this board, but it will go here because that LED is directly connected to AC mains and is indicating, if the heater is actually, if it's getting power. Just a failsafe. Or maybe, a failsafe. So, let's go with that. First thing I notice is, okay, I'm using here 2.54 millimeters and, units. Okay, let's switch to inches. Okay, so a tenth of an inch, that's not working. So let's go to 0.05 inches and still no luck though, huh? Can't place all my displays on here. Let's zoom in a little bit on that display stuff. Maybe 400%. It's not that I'm wasting space here. Nope. Okay, that's a challenge. And I have to go back to the drawing board. That's what's happened when you lay out a front panel. I just, in height, centered these two displays here. And now I need a measuring tool to tell me how big my board should be. And it says in inch. Okay, sorry if you give me millimeters any day. It says 24.97. Okay, so let's make our board 43 millimeters in height. Should be okay. Maybe I have to take the file at some point. Working on the enclosure, but should be fine. I will adjust just the board dimensions. You already see me do that. Okay, I adjusted the board a little bit in size and I'm going back, just for your benefit, to inches. So I'm at 0.025 inches and I'm adjusting the other two displays. And now I want these two displays to be centered. So there are several ways to go about that. I mean, I could get out the calculator and you can get somewhere the x and y coordinates and enter it numerically. But I just, set up two measurements and then we wiggle them around until, both numbers are equal. I hope that works out because, sorry, I also need space for my rotary encoder here. I don't want to put them any closer because these are Chinese display modules and their dimension might vary. Yeah, the problem here is I'm adjusting or basically have centered my parts up on my grid with the pads, not necessarily with the displays themselves. So there's a problem, but shouldn't be too big of a problem. I just have to wiggle a little bit more. So I also want my rotary encoder here on the same height. Yeah, let me wiggle. Can show it to you. Yeah, pad properties. Yeah, on the x-axis we are at minus 30.37 millimeters, and I need to go over. So we have to move 415 in this direction. 29.955. Let's try that. Oh, almost. Had somewhere a typo, I guess. There's still missing 4/100ths of a millimeter. Uh, well, maybe let's zoom in. Yeah, there's still a bit of separation. I'm happy. You see the principle, I will jiggle around my parts a little bit more and then I'll come back to you. Okay, I placed and aligned all my major components, which will be visible on the front plate. And I also placed here, yeah, it's on top SE, that's it, quite correct, but I don't care. I placed the shape, just a rectangle, and then I aligned that rectangle, yeah, using the calculator and its coordinates. Anyway, that rectangle is a mains AC switch, which will be not included in the board, but will go onto the front plate. So yeah, I have to leave some room here for later. Okay, let's start routing. And we go to inches. Yeah, 0.025 inches. That should be close enough. And if you go onto a pad, you automatically see all connected pads. And it shows you, at least for a short while, on what net you are. I'm here on ground. That's why I named all the nets. Okay, so these are my ground pins. And yeah, let's go to the bottom because it will be a one-sided board, which I will etch myself and place the first trace. And for now, I'm absolutely not concerned with the size of the traces or the pads. It's really just layout work I'm doing. There was something complicated here. That doesn't look right, but here I have VCC, or my 5-volt net, and there must be a resistor, my R7, I guess. That bill has to go over there. And also here you can use the R key to rotate if you don't want to do that. Yeah, there's a rotate here. I never use it somewhere. Rotate. R. Oh, okay. R, R, R. And maybe we should rotate that too. Bend that out here. And yeah, the 45 degrees angle, I will do all that later. And now you see what you have made me do. I placed that trace on the wrong side of the board. That's no problem. You simply have to change the trace layer to bottom. Okay, more ground. Okay, I need a ground between here and here. Okay, that looks much better when we now take our ground pad to somewhere it might belong. And yeah, I have space below these displays, okay? They are on standoffs, so I can place stuff down here, no problem. We have our 5 walls, and yeah, I'm one of those people who don't who don't use auto router. And now it gets tricky. So display data is also a new connection, and I want to avoid a problem. Display data with yeah, my ground and power, and we still have to do all that small stuff there. Display data, let's put it here, and you see we have maneuvered ourselves into a trap because now I cannot go up here. There is, yeah, this will not be a board area. I will cut the board here. Yeah, I need to cut the board here so I can fit in the AC main switch in the front. Okay, as I said, I do the routing all by hand, and I'll come back to you when I've done the routing, okay? Just a quick update in between, yeah, so I single-sided board, I ran into a problem. So especially for my 5 volt and for my ground rail, I will do some wires on the top side. And the way you do that, you place some pads somewhere, and then yeah, I'm on the top layer here. I connect these pads. Okay, I could align them a little bit nicer. Okay, I connect these pads with a trace, of course. Okay, but I don't have traces, yeah, remember, on the top side, so I can simply change the segment layer to top jumper wire. You see there's also a bottom jumper wire, but I want a top jumper wire. And you see it changes color to the nice green mask. I'll go on fiddling around with the stuff here. Yeah, I'm almost finished with my layout. I only have one trace here, which I need to connect. Yeah, there's that missing red line there. And yeah, I need another wire bridge, so I remove this segment here. Yeah, just the straight line, that's unroute segment. Yeah, trace would be from pad to pad, and net, yeah, the whole net, obviously. So unroute segment, and I place another pad here. And then I go to the top, and I already shown you how that works. I do the trace between the two pads, and then I'll define it as segment layer, top jumper wire. That's it. And yeah, we're done. So there, not quite. You see, if you have some errors in your layout, it makes a red circle around them. So here I'm routing traces through, yeah, mounting holes. But I won't use these mounting holes. And here, yeah, you would have to go back to the footprint and adjust that, because here you cannot simply say, okay, yeah, properties, blah, blah, blah. And you can update the component from the library with a different footprint, okay. That would be possible. And I might have to need to do just that, because you see, I have the traces here, but if we go now to File, Print Preview, okay, and I just want to see my bottom layer, and I just want to see my traces. Everything else is uninteresting. Traces and paths. I need traces and paths. Oh yeah, it does the traces. It does the traces. That's good. So you get a warning, but if you route a trace through a mounting hole, which we are not going to drill and not going to hole, but yeah, it gives you a warning. And if you want, you can simply go to verification and hide the errors. Yeah, after a while they will pop up again as soon as you touch that trace. Okay, so that's my layout. And I will now define the final board dimensions. That is, I take a rectangle out here for the AC main switch, and I will take out a rectangle here, because there comes yeah, AC mains connected LED. And yeah, I don't, the board is too crowded for, yeah, for my taste, for putting some AC main stuff in here and trying to keep it isolated. So let's do that. So you can add board points. I need one here. Well, not exactly here. And I need another one here. Okay. And now I do everything else numerical. So this point is at x minus 2.815, and we're in inches. Okay. Doesn't matter. No, does matter. Let's go to metric. So -7. It's also about rounding errors. Yeah, you don't. Then in the end, if you have rounding errors, the line is not really straight. Okay. That goes a little bit out. And the next one in y direction, -21.5. Let's look at that one. Yeah, you see, it's not exactly where it's supposed to be. I need to go 11.705 inwards. Yeah, we are at that point here. That should go, no, that's exactly staying where it should. Ah, okay. There's the undo function. Did I mention that? That will go up here. Now we can go back to the board points, and that was this point here. And in the y direction, this should be 0. And from minus 71.5, we need to go inwards, yeah, to the edge of my display, 11.705. Okay, that's where I need the calculator. 59, okay, control copy. And okay, not taking the wrong point here. Control V. And we do the same for the x-coordinate of that point. So this will be my final board outline. And I will do that for the other side too. Okay, I have here a trace that obviously has to disappear. Cut off that corner here too. I'll see you then. Okay, yeah, I cut out here that corner of the board and yeah, let my OCD run wild until I had a layout a routing that I actually like. Okay, we have these three jumper wires here, but there's really nothing I can do about. You could eliminate them probably if you had this part of the board and could route things around here, but yeah, space restrictions. Okay, so I have to live with 3 jumper wires, which is a new record for me. I think the highest I had so far was 1 jumper wire at one time. Anyway, the next thing I usually do is, work a little bit on the pads because, these round pads, I don't really like them. And by the way, I have all 90-degree angles. This will change too later on. You can, of course, in DipTrace start with a routing mode of 90 and 45 degrees lines. But just for visual clarity, I like to start with 90-degree lines. Anyway, I wanted to change this pad here, for example. Pad properties, yeah, you can use the patterns, pad properties, yeah, from the library. I don't want to do that. This is rather large. What the hell? Okay, and I'm, in metric again. So I say 0.8 and 1.6 and 3.2. Let's see how that looks. That looks awful. That looks in the wrong direction. So 3.2 and 1.6. And I want to apply that to all similar for the selected pattern. The selected pattern is my resistor pattern. And when I click OK, hey, it doesn't work. Okay, again. Nah, sorry, wrong. Okay, that's much better. And yeah, it searches for similar pads. Obviously, there are a few it got here, but a few it missed, which is not a problem because I can simply go in here and say pad properties. Okay, So these were my resistor pads, and now and you see now I have a little conflict here. Okay, but that's not that bad. I will now, yeah, adjust all the pads, and then I'll see you again. The pads are all placed, but yeah, my silk screen does look a little bit funny. Um, yeah, but you can adjust that. If you go through the properties of a part, there is a marking pads here, and yeah, for these ones, top justify is okay, but I need to shift them a little bit. Was it shift or spacing? So I go, say, 2.45, a tenth of an inch. And yeah, that's the wrong direction, obviously. Yeah, that's okay. And I will, yeah, adjust the markings of all other things accordingly. And yeah, then I'll come back to you. Okay, wrong side. I adjusted the silk screens a little bit. Not that I'm creating Gerber files and sending that out to a PCB manufacturer, but yeah, at least I can print out the silk screen on some paper, and yeah, I can read it. For example, yeah, all the connections here that go into the flat flags might be helpful. Um, yeah, for a production silk screen, there are some issues here, like yeah, having the labels of all my passive components inside. Yeah, so when you place the components, it's okay, but as soon as you are debugging and searching for R6, yeah, it's here, but you won't be able to read it. Anyway, I also, yeah, twiddled a little more with the layout. I like it. It's yeah, you go over it doing the silk screens, and you see, okay, this doesn't look right. Yeah, for example, I placed that R7 a whole lot more to the left, yeah, relative to the display module, in, yeah, in the same position as these passive components. The reason being, if I can find it now, yeah, I said in the beginning, I have a lot of space. Yeah, there will be some standoffs here, so that's the line where the board will be. I have a lot of space, but I also have here on the, yeah, on the left of the modules, that big capacitor, and I want that area to be clean of any parts. Just some things to consider if you are too lazy to make 3D models of your stuff. Okay, at that point, and you know I have here these pads already created, and I can, yeah, I don't know if I've shown that before, but you can place a pad anywhere you want, and you can actually edit that pad properties, and the same like for every other pad. This is 2.5 by 2.5, and it's oval, and the inner diameter, this is 0.4. Yeah, I need these pads to place screws. That's also something special. I mean, I have here my yeah, drill positions for mounting holes, but since I'm etching the board myself, I have to place these pads here. And yeah, I know that this one, M2.5, there will be one here. Now, placing these pads is a little bit more fidgety, because I want to place them over that hole, that hole, that hole, and that hole. So again, the displays will be held down by yeah, the connector, 4-pin, and one additional screw. That should be enough to yeah, make it stable. Anyway, yeah, how can I position these things here? I mean, if you and we have to go to the top layer. If you go here on a drill hole, you see it gives you the yeah, the exact coordinates, but you cannot edit it or copy paste it. And these coordinates are also relative to the part. So best thing to do here is, yeah, to take your measuring tool, and I go from that board's edge here, and yeah, let's go to 400% so you can read it. That's 68.665. Okay, so we need a calculator again. If you do such things, you will need a calculator, inevitably. Okay, but my board outline on the x-axis is 71.5. So I can simply take 71.5. Yeah, and of course that's negative 71.5. And yeah, go back here on the x-axis 68.655. So plus 68.655. And this should be, I do a control copy, the x coordinate for my pad. And I have a second pad down below here. So yeah, give it that x coordinate. And y coordinate, yeah, basically the same. Okay, so I will place my pads now here, which are just, yeah, for drilling purposes. And then I'll come back to you. Okay, I placed all my, yeah, pads where I will drill, and I'm, yeah, not happy with all of them. This is quite messy and this is quite messy, but I have no other space where I could put them. Yeah, I thought about, yeah, putting them up here. There's space, but yeah, I need the mechanical stability right here where my rotary encoder is. And yeah, there's also a little hole. This is just a location hole when I later drill the hole for the rotary encoder into the front plate. And yeah, don't need that for the LED. I can, yeah, guess that just by looking at the pads of the LED when I put the board down. Yeah, and now I usually would start to optimize or yeah, to modernize the routing of my traces. Yeah, just making small adjustments. And again, you can do that right away. Yeah, and you can define your own routing modes. I never used that, but it's absolutely possible. Okay, and so I go around and make everything nice. Okay, I'll come back to you when I'm finished with that stage. Yeah, just in between, I have here, yeah, a little problem, and I need to add here nodes, and there's this free trace editing mode. So I can go here and say add node, and add another node here, and then I can, yeah, raise that up. I cannot only shift, but I can add nodes. Yeah, that's all. Yeah, I think that's it with the traces, and now we can Yeah, fiddle a little bit with the trace width. And yeah, you just go on a trace, right click, and then you have, yeah, tune a single segment or a trace or a net. So 0.33 is a little bit thin for my taste. So let's take the calculator. So 2.54 divided by 4, 0.635. That looks better. And yeah, I have a few traces here where a lot of current is flowing, yeah, to the displays. And there I can say, okay, trace width, it's already custom, but I make that especially thick, 1.27 millimeters, and that one too, and so on. I come back to you when I'm finished. Okay, that looks pretty good right now. Let me open another PCB layout and take the writing that's on the wall here and put that somewhere here. And yeah, you can of course add any text. Yeah, I'm on the back side of the board, so it's mirrored, which is okay. Because yeah, when you look then from the back of the board on the traces on the copper layer, yeah, single layered board, it will appear the right way around, unmirrored. Obviously, I don't have that much space here, so I need to make it smaller, and so on. I come back to you when I, yeah, placed the writing. And it's done. Done and done. One thing left to do, and that is to copper pour. So you see, I'm placing that not exactly on the board outline, because that would be too fiddly. Just placing points roughly around here, and you stop with yeah, you stop with enter. Okay, clearance. I want a little bit more than that. I want a clearance of 1 to 7 millimeters, and yeah, line width spacing is okay. Island removal. We will probably see what that does in a minute, because I guess I will have islands and port, and if we say okay, you see, bullshit, huh? This didn't work at all, because, yeah, outline. Anyway, uh, no trouble. Just select it, properties, and border. There are all the points, and you can edit them manually, which we will do. So point 1, and oh, did I do that? Yeah, I'm cheating now. I'm cheating now, because I know this point here is 71.5, and this point here is 21.5. I think so. Yeah, got it. But we could also select our board outline and have a look here. 71.5, 21.5. Okay, so back to our copper pour. So the next one, 0.2, that was over here. So I know that's 21 point, no, that's not 21 point, oh yeah, 21.5 at the y coordinate. Next point, and yeah, it's not as nice as the board outline. You cannot interactively see what's happening here or what you have selected. So it's yeah, a bit tricky. So I tell you what, you see the principle, and when I place the board outline, the copper pour, I come back to you. Okay, so obviously I've done something wrong with the copper pour, so let's look at the properties again. Yeah, and you can say, okay, I want this unpoured. Okay, wonderful, there we are. And we pour it again, but this time, two little tricks. So my clearance is, of course, not 0.127 millimeters, but I want a clearance of 1.27 millimeters. Yeah, a 20th of an inch. And connected to net, of course, this is the ground plane we are pouring. Okay. And with the rest parameters, we can maybe twiddle a little when the need arises. And now we have to set it to port again. Yeah, that's more like it, huh? Yeah, we could, in theory, improve on that because of the holes. They are spared out. But the only thing I'm really concerned in is go my traces over these mounting holes that do not really exist on the board. Or do I really have to go back to my pattern here and correct it? I hope not. So let's look into the preview and bottom and objects. I just want the pads and the traces and the copper pour, of course. The rest I don't care. And let's scale that up a little bit so that we can see something. And yeah, here's my trace is going through, but it's ugly, isn't it? I have to get rid of these holes. Sorry, folks. Or we cheat. Cheating is always a possibility. So I tell you how we are gonna cheat. These are called islands, okay? And there's island removal, and I said my minimum, smallest island possible is 1 square millimeter, and they're gone. Only thing I could, oh no, there are more islands here, but I think they are okay. Tell you what, I experiment a little bit until I'm happy with the pour, and yeah, then I come back to you. That looks so much better. Yeah, I ended up actually using several copper pouring areas. Yeah, not only the patches I yeah, put around these mounting holes, but also, yeah, here I have one pouring area. I have another one somewhere. Come on. This is a small one. Here I have a pouring area, and here I have a pouring area. Simply to, yeah, spare out the ground lines so that they don't flare up. This is, yeah, didn't look nice, and yeah, I can live with the holes. that's okay. Yeah, we're almost finished. What I like, and again, this is not for sending them out to a PCB manufacturer, but if I do them myself, I like to place everywhere at the corners some traces, and they should be very, very thin. This will help me align my photo masks and stuff, and yeah, I usually do them only so I have yeah, some orientation where I have actually to cut the board and stuff. And now you see the hundreds of errors here because yeah, my my copper pouring stuff is not exactly yeah, on spot, and I yeah, poured over those mounting holes here, and yeah, you cannot send out that for production. But as I said, a lot that I did right now was to make this layout fit for etching it myself. Okay, I come back if I've done that. I think I'm done now. Yeah, I've placed here my reticules or whatever, so I can align everything and have no problems cutting the board on the saw. And yeah, in addition, I changed the diameter of all pads to 0.4 millimeter. That helps me align, yeah, the drill. Uh, yeah, you don't have, it makes things easier, okay? Um, yeah, I'm a little bit incoherent because this is really work I normally don't do at home. I do that best when I'm on a train. Yeah, no joke, on a train. Um, anyway, let's have a look at the preview. Okay, maybe not so much, and I only want pads. Yeah, that's it. Looks good. Ready for production, and it's really not that big, you know. Well, that was quite a ride, but making a layout for a board, if you yeah, have OCD, is really not that easy. Anyway, I hope you survived that. Till next time, bye.